My name is Abigail James and I am doing a presentation on the Generali Tower in Milan in Italy. The project, the Generali Tower in Milan, is 170 metres above the ground level and 185 metres above the foundation level, with a floor area of 70 metres squared. It has a twisted design from where each of the floors have a different dimension and orientation to one another, and the difference between the bottom and the top of the building is around 30 degrees, as you can see from the image on the slideshow currently. The Generali Tower is within the City Life new development in Milan, and it is above the Tre Torri station, which includes park space, civic spaces, residential areas, shopping districts and corporate offices. The Generali Tower is a corporate office which is owned by the company Generali. City Life is redeveloping the abandoned trade fairgrounds after the fair relocated to Ro Pero in 2005. The twist of the tower is to orient the top floors to Bramante's 15th century tribune of Santa Maria delle Grazie. The design of the building was mainly undertaken by Zaha Hadid Architects, but AKT UK also worked on the designs for the Generali Tower alongside Zaha Hadid Architects. The designs for the tower were based on the best views and were orientated differently from the building's reception position, which was necessary to be in one place. Parametric models were used to consider buildability, cost and robustness of detail. The angle of rotation was controlled carefully with a framework of rules to ensure the structural system could be controlled and allow for facade to core floor plates to be developed. The twist of the building meant that the self-weight would torsion into the central concrete core. The core must resist this alongside the normal loads from wind and earthquake events. This provides a complex interaction between the floors, columns and the core. On the slide currently shown is an image of the torsion working out with the models that AKT undertook. The structure of the tower was mainly undertaken the design by Redesco Structural Engineering. As the structure is complex, the leading of the project by Zaha Hadid Architects proved to be a key success factor for Redesco and enabled good cooperation between both Zaha Hadid Architects and Redesco to ensure that the elements of the building were optimised. There were complex problems due to the design of the building and its 30-degree twist from the bottom to the top. Redesco thought the best solution would be simplicity is complexity resolved. Therefore, the most simple way they can do it is probably the best way. The main challenge was how to cope with the torsion of the tower. This torsion is induced by the warping of the columns around the central core of the building. Redesco also needed to ensure that the most efficient materials, shapes and construction methods were used for the design. Redesco carried out a thorough evaluation of the structural alternatives once the layout of the structural members had been determined. This evaluation indicated that reinforced concrete would provide the best benefit-cost ratio. Whilst using the reinforced concrete is more efficient, it also makes the structural elements much more complex to design and calculate than if steel were to be used, for example. As concrete is non-linear material and the structure will deform during and after the construction, it makes it much more difficult. Due to this, it was imperative that they understood how the internal forces and stresses would change within the structure to allow for the facade, internal elements and installations to be designed to strict tolerances and without any waste. All of the structural simulations, analysis, drawings and detailings were developed using advanced parametric tools and software. The final design was implemented in BIM. Ridesco's role within structural design of the tower was from the initial concept through to the construction. This enabled Ridesco to cooperate with the contractor to define construction methods, sequences, monitoring and checking of the structural behaviour. The foundations of the tower were poured by Holcim in Italy in conjunction with CMB, who are the main contractors on the project. The foundations comprise of 64 pile foundations, which are 1.5 by 36 metres, and they're arranged in clusters around the main load points of the building. Despite the soil being mostly strong founding soil, there were some pockets of weak and compressible areas which were found under the building where it should be. Ground models were needed to develop the best solutions to support this while still controlling deflections adequately. Therefore, pile foundations were found best to control this and were used to act as settlement reduction devices. A 2.5 metre slab, raft slab foundation was then cast on top of these. As you can see from the picture on the screen, that is Holcim actually pouring the concrete for the slab. This basically forms the main base of the building. The foundations were poured by jet in less than 48 hours and actually took a record for doing so. They were poured from 8 p.m. on the 5th of December until 6 a.m. on the 7th of December. And they used just under 8,000 metres cubed of concrete for the foundation. 30 cement mixers were constantly required over the period. The base of the foundation was poured using cement with a low heat of hydration, specifically designed to reduce the risk of cracking. The mix involved the use of a 32.5R IVA pozzolanic cement. Pozzolanic properties basically allow the control of the heat of hydration, which is what causes the cracks. The cement was then covered in mats after it was cast to prevent any moisture loss and again to prevent cracking. The core of the building, there is a perfectly vertical nucleus or core which houses the stairs, elevators and pipes for the systems. The core carries the floors and balances the torsion transmitted by the pillars around the perimeter of the building. Whilst the core is built with Perry formwork, the pillars start with a lateral inclination which is gradually reduced as the maximum height of the building is reached. This makes each pillar individual and has to have its own formwork due to the complexity of this. A 3D model and BIM was used for this. This slide just shows the layout of the elevators from the structural engineer's design. For the formwork, a contractor called Perry contracted to do the formwork for the tower. The floors needed to be constructed in continuous weekly cycles and therefore accelerated construction was needed. Completion of the shell was done in 17 months, which was actually 3 months ahead of schedule. The fast completion was enabled by the development of a solution with constantly safe and fast operating sequences. This solution was to ensure perfectly matched formwork and scaffolding, which combined climbing formwork solution for the core, gap-free enclosure for the top floors, and an anti-fall protection for finishing work operations. Safety was imperative on this project, and actually because of the system used, the safety was increased, which meant that the time taken to complete the project was reduced. Perry used a number of systems, with the main being a range of self-climbing variants which can be used for facades, building cores and shaft structures, so perfect for this project. This makes the construction of high concrete structures extremely fast, cost-effective and safe. The climbing units have a wall formwork and platforms which are moved from floor to floor by an integrated hydraulic system instead of having to use cranes. The sequence of operations enable a high level of productivity and short cycle times. They can simultaneously climb several units, which will ensure fewer leading edges and increase the workplace safety. The climbing units were connected to the building at all times, which ensured the climbing procedure was carried out quickly and safely, even in adverse weather conditions, particularly high winds, which you will get as the tower increases in height. The External walls of the core taper by 15 centimetre increments from 90 centimetres at the base of the building to 30 centimetres on the upper floor of the building. The floor slabs are 32 centimetres thick and revolve around this central core. Their geometry changes from story to story. A sky deck panel slab formwork was used for the slabs to ensure fast shuttering times and short striking times were achieved. This sky deck panel you can actually see from the image on the slide, which is what they were using for the project. The facade system is one of the main elements for this building. It consists of a double skin. The outer skin follows the twisted form of the building and is mainly made up of cold bent glass. Some warm or hot bent glass was used if it was required in areas of extreme warp. The inner skin follows a faceted form that approximately follows the outer skin, but isn't as neatly curved. The facade is an externally ventilated double skin, and the thermal line is set to follow the inner glazing line. This system can reduce the heat flow that would otherwise enter the building, whilst the inner skin is a floor-to-floor curtain wall facade system that allows continuous seals to be made from the facade to the slab at each level, and therefore the cavity finishes are less critical to the weather and vapour performance of the facade. On this slide you can see the first image is of the inner curtain wall systems being put in, and the second image is of the outer facade, and you can see the difference in the curved appearance of the glass. The mechanical and electrical was undertaken by Max Fordham, and they do engineering and architectural lighting for the project. The tower has a double facade system, as just mentioned, and it's also combined with sun deflecting louvers and natural ventilation slots, which allow to minimise the solar gain in the building and allow the cooling of the building naturally, so without needing too much intervention in that. Natural daylight is also drawn into the floor plate, and the facade allows clear views out of the city. The image on the slide just shows the amount of natural light coming through, and that's even with the shutters down. So they didn't need too much lighting inside the building. The other interesting thing about the M&E is that a low energy active chilled beam are used for heating and cooling the building. And you can see from this image here, it's just at the top of the screen, and this is a more detailed depiction of the active chill beams, which uses a heating coil or a cooling coil to cool the room temperature and also to heat the room temperature. This helped to contribute towards their LEED Platinum rating. The lighting was also integrated to complement the architecture. The lights on the office floors follow the curve of the floor plates, and luminaires are concealed within the chilled beams and the ceiling profiles. There is plenty of daylight, and artificial lighting was carefully controlled to ensure appropriate lighting. Awards. They have actually managed to get a LEED Platinum certification from the US Green Building Council for the core and the facades, which is due to the ventilation systems and the sun deflecting mainly. They also placed second in the Emporia Skyscraper Awards, which is a pretty good achievement. Finishes of the building. The main finishes to be noted are the curved wood, which is actually in the podium, which is sort of the atrium to the tower. The atrium holds the shopping district adjoining the lower levels of the tower. The internal wood finishes curve and match the external curve of the building, which integrates the shopping district and the main tower. I think it's actually made of curved bamboo to form these structures, as you can see in the images. and further images here. So they're still using really good use of the light and different shapes of the building. Conclusions. The design of the building is really well thought out and very unique due to the torsional twisting structure. The use of the twist to orient the floors differently from one another provides the best views from the tower, which I think is very important, alongside the use of a double facade system, which reduces the heat intake of the building, and with the sun louvers and natural ventilation, the building has been awarded a LEED Platinum certificate. Despite this, much of the building is formed of concrete, and the eco considerations have not been undertaken throughout the whole project. There has, however, been some advances in technology, particularly within the pouring of the foundations and the formwork technologies to advance the project quickly and safely. That's everything. Thank you for listening. Further reducing torsion. To reduce any more torsional effects due to the warped columns, core lintels were placed above main doors and are composite with steel, rebar and concrete, as you can see from the image on the slide. Furthermore, to combat the torsion at the tower, the contractors, CMB, installed metal into the core on each of the floors of the building. These were then pulled in order to contrast the torsion from the outer structure. So they would have done that on all of the, I think, 140 floors that the building has.